Uh-huh. So, okay. Eigenvectors and eigenvalues are named after the German mathematician David Hilbert. The prefix eigen can be translated as own or characteristic. So sometimes you'll get what's called the characteristic matrix. Okay. And there's a interesting way to do this. And they prove to be incredibly useful. There's a whole lot of strange applications to them that you're like, why does that work? And all I will tell you is somebody has proven that it does, or it wouldn't be taught to you. And you're just going to accept it at that and go, I don't have to prove it. Um, the special nature of these values and vectors in relation to a matrix, sometimes eigenvalue and eigenvector are referred to as characteristic values and may be called that in other languages such as Spanish, which there are autovalores and autovectores. Okay. In this concept, we will learn how to diagonalize a matrix and using eigenvectors. Rewriting a matrix in equivalent diagonalized form allows you to easily find powers of a matrix. How do you patterns in a matrix? It's easier to find powers and diagonalize. Now it's easy to do powers of a matrix on your graphing calculator. It's not so easy to do them by hand. Like a matrix cubed when you have to multiply it and then multiply it again. And that's not that bad. But think about it to the 10th. It'd be pretty awful. So the diagonalizing is actually easier. And I'll show you why when we get there. Um, but first you need to learn how to do this. And one of the big reasons you have this Inspire calculator is because it can do that. The eigenvectors are a little screwy. Did this literally just fall off my sprinkler? Interesting. Well, moving on. One thing that's important to note with matrices, each column in a matrix is considered a vector. Okay? And it can be treated as a however many dimensional vector.
Only the columns, they're not there.
Yes, each row is like XYZ or XYZW if you want a four-dimensional vector. Or you can have the beautiful thing about math is the math works the same no matter how many dimensions your vectors are. So you can have a 32-dimensional vector. What does that mean in physical space? No idea. 3 dimensions makes sense. Fourth dimension would be time, so I suppose you could put that into vector form. But if some of the theories that the universe is more than 4 dimensions are correct, the math already exists. So, and some of them are based on the math works, which doesn't necessarily mean that the theory is correct. But one of the arguments in physics um, is that a lot of times the math has led us to the reality. They figured out the math before they figured out that it was actually right. So, to find an eigenvalue and their eigenvectors, you can rearrange where this lambda is eigenvalues and x is eigenvectors. Okay. And
lambda equals eigenvalue, X equals eigenvector.
Mm-hmm.
Is this like just always the notation, like for just?
Yes, lambda is going to be, we're going to call them. So the ones you're going to do by hand are going to be 2 by 2. You will get two eigenvalues, lambda 1 and lambda 2, and they will correspond to two eigenvectors, x1 and x2.
Okay.
And this is the officially what it means. You can subtract lambda x from both sides and get this. You can factor out the x and you get this. Do you know why they put the I in?
Identity matrix, but I don't really know why they would put it there.
So lambda here, they're only giving a single lambda. These are a scalar. Eigenvalues are scalars. So you need to multiply it by the eigen or by the identity matrix to have it be a matrix. These are vectors.
Oh, okay.
So we are told that we are looking for when the determinant is not equal to 0. So what do? We actually set the determinant equal to 0 and solve. And this is what it actually looks like. So I'll show you the little bit of theory, and then from after this point, we will jump straight into the easy way to do this. So that's my theory. So I'm trying to find this when it equals 0. So I end up with this when I put it into a single matrix. So 3 minus 1 times that, 5 minus 0.
This is just matrix logic.
Mm-hmm.
We just plugged the one vector really into
Yeah.
our equation.
So what it comes out with is every time you just take your matrix and you go minus lambda on the A and the D spot. And then I'm looking for where is determinant equal to 0, which is AD minus BC. This is A. Minus BC. And then I'm going to FOIL it out. So when I combine like terms, 3 and negative 15 gives me the negative 12. Negative 3 lambda and negative lambda is negative 4 lambda.
Okay, we did stuff I just lost that.
Now I factor.
What?
solve by graphic. Your graph equals your axes. Will be ending. So I don't know. We have some right that showing right on the rest fun.
There's two values because it's a 2 by 2 matrix, right?
Mhm.
But really, it's just
I believe a 3 by 3 would have three. Well, when I show you how to do the calculator, we'll do a 3 by 3 for the heck of it. Does that kind of make sense?
yes.
It's not actually that hard. You just have to remember what to do.
It's like this. It's like I think it's like very similar to a few of the costs.
But
When it said find when the determinant is 0.
oh yeah,
Yeah, there's like a
and it had some X's in there, and you have to start by plugging them in. So this one, find the eigenvalues. Same thing we just did.
one time I did that problem right and they the quadratic formula.
Oh yeah,
It's very sad.
the yes, welcome to A and I, where you spend so much mental concentration on the new stuff that sometimes
for figuring it out though.
that you can't do the basics anymore. And like there's a point where we like we have to drill some of these things so that stuff like the quadratic formula is so automatic and it's mostly there.
That it was.
Yeah, but that's why we drill it a lot, trying to get it to be completely automatic so that you can just do it. Okay, so now I'm setting the determinant equal to 0 again. AD, that's not an X, that's a lambda, minus AD, there it is, minus BC equals 0. That's a +8. That's a -3, -3 lambda, plus lambda, plus lambda squared. Um, and now I cannot solve this by factoring. Equals 2 plus or minus the square root of 4 minus 4 times 1 times 5 for 2 times 1. And we have complex eigenvalues at 2 plus 2i and 2 minus 2i. And those are my two lambdas. It does not matter which order you put them in. When we start doing eigenvectors, I believe the next example, then with the eigenvectors,
Wait, does not matter about like what order you put the eigenvalues.
the eigenvectors have to correspond to the eigenvalues. So here's what an eigenvector looks like. And we're gonna now find the eigenvectors for our first example. So find one eigenvector. The first step in finding an eigenvector is finding the eigenvalues. So these are what we got when we did the eigenvalues. Now, an eigenvector. we had this for our what's called, sometimes this is called the characteristic matrix, I think. And this is times some vector has to equal the vector 0, 0. So what I'm going to do is literally plug in one of the I'm going to plug in one of the eigenvalues. And this will get me the corresponding eigenvector.
Wait, what are we plugging
So I took eigenvalue 1. I would do this twice.
in? It doesn't matter where I plug in the eigenvalues.
I plugged them in for lambda.
Yeah, but well, earlier we wrote -2 as lambda 2, so could I put it in the bottom, like 1 minus -2 and 3 minus 6?
No, they have to be the same.
Oh, okay. No, I see what's going
So you're plugging one in for both.
Yeah.
And ultimately, we'll go ahead and find both eigenvectors, and then I'll show the second part with one of them. And so then I do matrix multiplication, I get this. AB, so eigenvector 1 is some constant times 1 negative 1. Would that work out? So basically what I'm doing at this point is looking for an A and a B that work out to be true. And you can solve, usually we try to get whole numbers here instead of fractions. But you could solve either of these equations. It should work in both. The same thing. Now, an equivalent eigenvector is 7, negative 7. Or negative 7, 7. Both of those work.
Just multiply by a scalar.
I just multiplied by a scalar. They all work in these equations. Okay. The inspire gives you screwy versions. I bet you it's going to give you a equivalent of square root of 2 over 2 and negative square root of 2 over 2 when we do this in decimal form. So what I would say is my eigenvector is, I would do that one because it's as simple as you can get.
So if you have the eigenvector and I want you to do something with it, you should simplify.
If you
If
can.
they gave me 7, -7.
Yeah, I would make it 1, negative 1.
7 times
I would just say,
7 times 1 of negative 1 and negative.
yeah, the vector is really just this part.
Yeah.
There's a million, they will always say give an eigenvector. So if you come up with one that is true, it works. Okay. Unfortunately, these features get shut off, but when you take your exam. Yep. It's kind of lame, but now let's do it with, we're gonna do 6. This is BMT. Easiest eigenvector is going to be 5, 3.
You just like,
Pretty much just reverse them.
well, like
They'll show it to you like this.
this system.
No, you can solve either one of those equations because you need A and B. So 3 times 5, negative 3 times 5 plus 5 times 3 is 0.
So you just like added some stuff until it seems right.
I kind of just looked at them and went
I'm just
3 and
it's more complex. Can I just solve it like a systems of equation?
no, that you will never solve like a system. So here's how they show it. B equals 3 over 5A, but then you have to put it into a ratio. And so A would be like, you could do this as 5/3 1. It's called B1, and what do I multiply A by to get to 1? And then multiply them by 3 to get rid of the denominator is one way of working at it. No, you pick one of the equations and you solve it. Most of the time, I'm just looking at it going, okay, I look at this. Well, if they're both plus, one's got to be negative, right? I just pick one for negative, and I've notice that 3 times 5 is going to be 5 times 3. There's my A and B. It's almost like I'm doing a common denominator. Negative 3 times 5 is 15. 5 times 3 is 15. Negative 15 plus 15 equals 0.
Yeah. No, I'm like if I would have put 3 as A and 5 as
That would give you negative 9 plus 25. That's not 0.
oh, never mind. I see it.
So like when you're doing common denominators like this,
Just was slow to get this. Okay.
you switch them, right? Same idea here.
What I'm doing.
It's something complicated and new, so it takes a lot of mental processing power. So the next thing, so we'll do it with this eigenvector. So these are my corresponding eigenvectors.
Weird.
And I would label them like this. With vectors, you do have to put the arrow above it. Even though the book does not, they do bold. You can't handwrite bold. So let's get rid of a bunch of this stuff here.
So that would be a really fun scenario, I think, especially, I know we should be like a dog, sometimes some. Not exactly like too much, but I think it's, we're she wants to something. Well, then we'll never figure out, bring it on. Which would be too bad, when we turn it on.
So now it asks me to show that A times eigenvector equals eigenvalue times eigenvector.
That was like 30 minutes.
It's true for the eigenvectors you found. No, it did say to only find one, but now it wants you to do it with both. Whatever. I have 3. Thank you. So now I'm going to multiply and get 15 plus 15 is 30. 3 times 5 is 15 plus 3 times 1 is 18. So I just did the AX side. Now let's do the lambda x side. The lambda x side is easy. That's just multiplying by a scalar.
Ah,
That makes sense?
What signs like? Oh, because ax equals lambda x.
Hmm.
Right there.
That's what we're supposed to show. So ax.
Showing that what you found is true.
Hmm. And we could do the same thing with the other one.
Proving that are eigenvectors.
You're essentially proving that almost just checking your answer. Because the formula we used was developed from this.
I don't.
So now we'll do the whole process on this next one. Find two eigenvectors and eigenvalues for this. So
S.
4 minus lambda. And you pretty much need to show this work. And it's really important to learn how to do these by hand, even though the calculator can do them. Well, also, you're going to have problems in the assignment with variables in there.
Zero.
Like if there are no variables, can I just use the calculator? I did a lot of stuff by hand just for the practice.
Mhm. As long as you,
Because I really didn't want to do the multiplication.
yeah, I mean, I did a lot of solving in their video by graphing because I didn't feel like working it out by hand.
Sorry to take as long.
Yeah, it's a 45-minute video. They also, yeah, your homework too. Yeah. I was like,
I did a few of the multiplications.
as long as you can do it successfully, that's fine. I'm like, it's a ton to write out. And we're gonna be doing it mostly by calculator if there's numbers.
I actually did good on the assignment.
Good.
Only one problem did I actually just like completely get wrong.
That's pretty low for us.
Stupid mistakes on the other two. Like it would have gotten it right if I would have done like easy stuff right.
Yes. It's 10 lambda plus 21. Okay, this is an easy one. Lambda minus 7, lambda minus 3.
Makes.
Okay, so
Actually, yes, it's for. Oh, what about adolescents? So that's kind of option. Try to focus. On. Oh, he was born. We're on 3.
so now I plug them in. I guess I better write this out. 1, 1, 3, -1. Oh, wait. That's not right. I have to use the same eigenvalue for both.
Yes. And then the entire thing. Sorry, what?
So this is one of these basic ones. 1 and -1, yeah.
With Minecraft, that's fun. So I'm very, but realize that did actually show from the remote, and then the other one was like bad.
Do I have to add the t?
No. So the eigenvector,
It's a value, not.
The vector, it's the vector, yeah. T is just because it's always find,
No, that these.
yeah, that any scalar is an equivalent eigenvector. Okay, any scalar multiple. Yeah, you don't need that because your vector is just the simplest version you have. Now let's do the other one. 4 minus 7, 1, 3, 6 minus 7. -3, 1, 3. -1.
What is that? A1. A1. This is all L. I'm just waiting for this.
Wait, is what I think? Maybe it was like. Well, the 22-year-olds like up to the ratings of 7 years. It was no more.
I am so proud of this generation. I'll be the first to say it.
So 1 and 3.
Wait for this. I saw this at night, then I realized that girls are like our people too, you know, they're like, I thought that they were like.
So those are my two eigenvectors and eigenvalues. Oh, and it wants me to find two eigenvectors for each value. Okay, fine. Multiply by a scalar. Let's just switch them for that. Let's multiply by 2 for the second one. Yeah, so I multiplied by -1 on the first and 2 on the second. Because what the heck, why not? So yes, multiply by any scalar.
No.
Okay. And that's the end of this section. I do want you today to do these 4 questions at the end of the section that are directly related to this before trying an assignment that's going to have most of the questions that you don't know how to do yet.